Cool. So we can start now. Just an introduction. My name is Nirmaljeet Singh. I manage observability at CRED. Most of you would have heard the name. Cool. So I will give you some short context that what is this talk about. So as systems scale, the cost on the cloud part also increases a lot. And to manage all that thing, you need observability in place so that you can know that what is down, what is up, what should I do if my deployments are failing, all those things. So at CRED, we had Victoria metrics for basic metrics. We had Coralogics for logging part, and we had Datadog for tracing part. All of these, if you combine, were more than like $2 million per year. Logging itself was $750K a year. So if you see that from a business perspective, that is like a huge money which you're paying to a SaaS solution, instead which you can build in-house. Maybe the features won't be same. Maybe some of the metrics will come a bit late, maybe by a few seconds. But is it worth the cost which you're paying to a SaaS company? So this is the journey which we recently had at CRED, where we moved entire logging structure from Coralogics to in-house logging platform, which was built on Loki. So what was the challenge with Coralogics? First thing was that the operational cost was too high, around $750K a year for the existing business which we had. And these businesses are always expanding in nature. Being a fintech, you have to take care of a lot of things, be it DR, be it new compliance checks, be it storing all the logs for more than 2 years because someday a new auditor will want to see it. So you have to keep track of everything. Moreover, there was that TCO problem as well. If you don't know TCOs are basically the quotas. Let's say some developer accidentally enabled debug logs, and that is going to full your, like completely choke your entire quota which is there. You don't want to do that. So you have TCOs in mind that if something like that happens, I will stop logging that particular service. But that is not a solution for long term. What if someone wants to just enable debug logs to verify what is wrong with this service? So keeping these points in mind, we realize that this is not going to scale based on our capabilities. So we have to build something in-house. Then we tried a couple of tools. We tried Elasticsearch, we tried Signos, we tried Loki as well. We did a performance benchmark of all of them. And then we later on realized that which is the one which is fitting in our use case the most. Hence, we went along with Loki. So if you see the daily log ingestion, that is close to 15 TB. This is like a 2-month-old slide, which is close to 18-20 TB now. And moreover, during the first 5 days of the month, which we call as the credit cycle, when you pay your credit card bills, this log increases up to 20-22 TB as well. And this is just for the main business. There are subsidiaries as well, which are not accounted here. So coming back to the cost part, from $750K, we have brought it down to $150K a year, which is saving of approximately 600K. That is a huge saving if you consider that. Then what do we get from that? Now you can just ask the developer to enable TCO, enable debug logs, whatever they want to do. Now you don't have to think about that. If I send these much logs, will my application stop sending logs at 4 a.m. in the morning? Or the on-call will tell me that please don't log so much. We gave them the freedom which they asked. So yeah, we got better control and customization from an in-house solution. Then if you don't know that how does a logging infrastructure work, this is a very high level thing that you have your main application, let's say your auth service, which every organization will have. There will be some agent, you can say FluentBit, FluentD, Promptail, Grafana Alloy, anything, which will just read your logs and send it somewhere. It can do processing in between, it cannot do processing, depends on your use case. In our case, we just used to read the logs of application, send it to Coralogics. Coralogics would be the main part where we will do all the aggregation, customization, log parsing, setting up alerts. All that thing used to happen on Coralogics. And ultimately, that data would get compressed and stored on your object storage. In our case, it was S3. Can be GCS, can be S3, anything where you want to store the logs. Now what we did, So we kept the fluent bit as it is, although we are moving to hotel, that is a different thing. So we kept fluent bit as it is. What fluent bit in our case does is that it will just read the logs. We'll do some metadata enrichment on top of that, do some parsing, log drop, all those things on the fluent bit level based on the requirements which we have set up on our parsing layer. Then we send these logs to a middleware, which is written in Golang. What it does is, if you know that in fintech, you cannot store the logs which have PI data. Let's say you are doing some transaction, which is a UPI transaction, or you are paying your credit card bill. And if I'm printing your PAN number, your name, your mobile number in the logs, and I'm keeping them in my entire database, that is compliance, like that is not approved by compliance. You cannot do that. So what you can do, we can just mask everything. Like being a user, as in if I'm a developer, I will obviously go and read the logs. I need them, but I don't want to see your PAN number over there. So we have to redact them. We have to parse them. Basically, your entire string will be just marked as X, Y, Z, something like that. So that no one in the company knows that which user did something. I only want to care about the error log which was there. That is the main thing. So we build this middleware where we send everything from your fluent bit to this middleware, where I have implemented the rate limiting part or your PCI data redaction, everything is there. I maybe want to do some transformation over it in future, from where I can just send some metrics over there where I can do some correlation as well. So this middleware is responsible to handle everything based on that. After this middleware, after all these transformations are done, I send them to Loki. Instead of CoreLogics, which you have seen in the previous slide, now I send them to Loki. In our case, Loki will do the same thing. You can query the data, you can just write your logs over there, you can build some great dashboards, you can search some string that show me the logs of XYZ service where this string was coming. I can do that on Loki, which is basically done by developers wherever they want to troubleshoot. So this is the current architecture which we have. From service, FluentBit is reading everything, setting to your middleware proxy, that is doing the basic transformation, sending it to Loki, where we are writing everything, keeping the data for some cache, if you want to like query some recent logs and everything, and then ultimately sending it to S3 for long-term storage. On S3 again, we store them for a while, let's say 6 months. After that, you put that into cold storage to save cost. So all that thing is like done on the Loki end.
Can you quickly just show the older architecture so that we can go?
Yeah, sure. So only one thing is changed. Instead of CoreLogics, your middleware comes, which sends it to Loki, ultimately to S3. Loki is basically your log aggregation platform where you write the data and where you read the data. So basically, I want to read the compressed data from S3. How will I do that? There needs to be a query in between which has the logic that for this particular index, where is the chunk stored? So I will come back to the write and read path of it. No. So FluentBit's responsibility is just to read what is coming in the application and send it to somewhere. It is a stateless thing. Moreover, if you don't consider the caching part, FluentBit will not store anything to its own. Its responsibility is to just make sure if I have received 100 log lines, I send 100 log lines. That is the only responsibility of FluentBit. So yeah, we manage a 600K annual savings, eliminated license cost of CoreLogics. Basically, whenever you see a SaaS solution, it may have licensing cost that for 100 users, you will pay XYZ. For 200 users, you will pay something else. Then we optimize the chunk storage, reducing overall S3 cost. So in our case, what used to happen was the 750K amount, which I was telling you, was just the CoreLogics cost. That did not include the cost of S3, where the data is stored for 1 year. So we optimize that part as well, so that we compress the data in such a manner in S3 that we use less storage and hence save more cost. So we now run Loki on a mix of spot and on-demand instances in Kubernetes, which again helps us to maintain availability and reduce cost. Basically, your write path runs on on-demand instances, and your querying part runs on a mix of both of them. So in daytime, we increase the number of on-demand instances, reduce the number of spot instances, so that there is zero chances of availability issues. Like 1 in 100 thing can happen, but again, it's just a querying part. If someone is not able to query right now, maybe after 2 minutes he can query. The main thing is there should be no log loss, which we make sure that all the ingesters and the distributors, basically the components involved in the right path, are always running on the on-demand instances. Then we eliminated network cost for sending data from our infra to Corologics. Basically, Corologics used to run in their own VPC. We had our own VPC, so there was a inter-VPC communication and a lot of data transfer. And data transfer, if you are talking about 20 TB a day, which gets to 600 TB a day, is a big cost in itself. Now we have it in our own environment, so that cost is also reduced. So yeah, we have 15-20 TB log ingestion per day. We have a query latency P99 of 40 seconds, ingestion latency less than 5 seconds. Its availability and reliability was the main concern for us. Speed, it's okay. You might not be able to query data in 5 seconds. It may take 20 seconds, but again, it all depends on the cost, how you have optimized it. These are some of the metrics which we currently have. If you can see, ingestion latency is somewhere around 4.75 seconds. These are like 60, 80 queries per second, which are always there. Then your query latency, if you see, 44 seconds is there for your P99. Query success rate dropped down here in 97%. So one more thing is that when we say that query success rate dropped, that does not mean that query was not able to query the data. The problem is, let's say I am a developer who don't understand how to query the logs. I run a very bad query. Let's say I have just written that, show me all the logs of all the applications for last 1 year. Do I want my system to scale that? I don't want to do that. Otherwise, my entire system can go down, because querier will keep on running, trying to get data from your S3, from your ingester, wherever data is stored. Ultimately, it won't be able to give anything in the time which the developer is looking. Moreover, why is he looking? So we have set up global timeouts that if your query is not able to run in this much of minutes, this much of seconds, based on the tenants which we have, then you will get an error response that optimize your query, and moreover, all these things. Then how did we do a cutover in production? So imagine from last 5 years, 6 years, you're sending all the logs to a particular SaaS. Now, one day someone wakes up and says, we will move everything to in-house. That is not going to very well suit the agenda or the idea how devs used to query, because they're habitual to that interface. They're habitual to that way of querying. So cutover taking in such a way is a pain. So how did we do that? First of all, what we made sure was that all the new businesses which are coming, the main business remains as it is. All the new businesses which are coming will be onboarded directly to Loki instead of Corologics. So this gave us two things. First thing was that now I don't have to migrate this new business to from Corologics to Loki. This was the first thing. Second thing was, it gave me more confidence that my system can scale. And if I want to pitch this system to someone, some other dev or some other architect working in the main business, it will give me more data points that, see, the latency is this much, the cost saving is this much, and he or she can be easily convinced. Second thing was that on Corologics, we had close to 700, 800 alerts based on logs, that someone would have said that in my service, if this string comes for more than 5 minutes, for more than 5 times in a minute, send me an alert. Although we don't appreciate setting up alerts on the logs, should be on metrics and traces, but it's okay. So we had to write some automation so that you migrate all these alerts from Corologics to your in-house alerting solution. Now the problem comes is that Corologics, being a SaaS, had its own way of querying. On Loki, you have LogQL. That is a different querying language. So how will you do that? So we wrote a simple MCP server, gave all the context to him, gave him both the endpoints, showed him a few examples that if the name of service is auth, here you will write app equal to service, something like that. We built an entire MCP server which will do that. We did some iterations, had a maker checker in place so that the developer can just verify if this is the expected thing, or do he wants to keep these alerts or wants to just delete them. So we did the production cutover like that. Second thing, after all this thing was done, we just announced it that we are going to remove CoreLogics on so and so date. Till then, you will be able to find logs on both the places. But after the cutover date, you won't be able to see CoreLogics. We will just revoke the access. We will keep the logs in storage for some time for audit part, but all the latest logs, you will have to go to Loki to see them. Why we did that? We gave them a month's time so that they are habitual to it. First of all, learning a new querying language can be a learning curve for them. So we built a NLP-based MCP server, which just asks them that just write in English, what do you want? So for an example, I can write show me logs of auth service, which have level equal to error for last 15 minutes. This will break down the keywords which I have in basic English language, convert it to logql, which Loki understands, get the data using an API, again, revert it on the screen, show it on a good UI. This is how we ask devs that learning logql might be an issue for you. It's okay. You know English. That's enough. Although we gave them documentation and everything. So that's how we took the cutover in production. What were the challenges? So the major thing was migration. How do you migrate all the data from last 5 years to now? That's a big thing because all that data storage is different. The format is different. Compression is different. Now you have something entirely opposite of it. How will you do that? So what we did was that we asked compliance that till when do you want the data for audit part? They simply said, we just want to see 1 year of readable data. So now we have that 1 year of readable data on CoreLogics and Loki by running it in parallel. That's how we just kept that data intact, and the new data is always being appended over there. Then we had a zero downtime migration. So AB worked here, basically running 2 stacks in parallel, and ultimately one day you decide to cut it off. Educating devs about logql, which I already discussed. Then migration of close to 1500 alerts. So these were the alerts which were sent on, which were kept on CoreLogics. We had to migrate it back to Loki. This was the automation which I was talking about. What were the technical hurdles? So high volume data ingestion. Now imagine you have 20 TB data of every day of just one business. Each second you are getting like thousands of requests on your app, on your website. So you have to build a system. Obviously here people would have like made systems which are even more scalable. But this itself was a good thing, good learning for us, the entire SRE team, the team which basically works on observability part at CRED. Then complex PCI data handling. So yeah, this is where the middleware thing comes here. So let's say today, being a developer, I am logging something as pan equal to this, username equal to this. Tomorrow, some other dev came, he said, it won't be called as pan, it will be pan number. Now, how do you identify these patterns? If a single string in your entire labels changes, your PCI data can get directly to your storage layer, which we don't want. For that thing, we build our middleware in such a way that it matches all the possible regexes and has a QA check before sending such kind of logs to your production environment. QA check is basically your QA team, which is approving that this logging pattern is approved or not. Yeah. Then query performance optimization. So being an in-house system, from day one, everyone wants to see the same behavior which they had on the SaaS platform. Comparing a SaaS platform to an in-house platform can be tricky, can be tough because they have an entire company doing that. Here you have 2 people doing that. So we iterated on top of it, changed all the possible config values, changed the way we compress the data, changed the way we query the data. That helped us to improve our query performance. It still won't be as same as that, which was there in a SaaS platform, but it's okay. You're saving the amount, which was the main concern for us. Then we had custom retention policies. For example, for a particular business, compliance says that it's okay, you just keep 1 month of data. We are fine with it. So we just change that. Now I don't want to keep 1 year of data for all the services. So we have custom retention policies. We optimize our query engine. We automated the PCI redaction part, which I just discussed. Then we have a distributed log storage. Now I don't care if S3 is down. If S3 is down, I will move it to GCS. I can build a DR on top of that. I am ultimately shipping my logs from low-key to a object storage. It is in my control. I can do whatever I want. I can store them on my local disk as well. So what are the key takeaways? So we did a significant cost reduction. We improved the performance metrics. We improved the data security part. And now we have a scalable in-house solution. Moving ahead, we are going to change how we do observability at CRED. Logging is done, metrics is done, next is tracing. We have Datadog, which all of you know how costly it is to run Datadog at such a scale. We are going to move everything to ClickHouse. It's going to be a data warehouse solution now, not just another observability problem where you have a couple of tools. The long-term aim is to move logs as well to same ClickHouse so that using OpenTelemetry, you can do a good way of correlation between your metrics, logs, and traces, which itself are events. If you don't look at in those terms, as in if you don't consider them as different, if you just see everything for me is just an event, how that happens in Kafka, this is the same problem. So we have a long-term vision of doing that on ClickHouse, but maybe that's for another meetup. So yeah, if you have any questions.
One quick question. You spoke about that conversion of a query language for the SaaS to the query language for your own product. So was that conversion for queries which already existed and like you wanted them to get converted into a new form?
Yeah. So basically, what happened was that when you use that another platform, they have something similar to SQL, not exactly SQL. They have labels in that place that select application logs from so-so thing, where timestamp equal to so-so thing, right? You want to just pick out that what is the result of this query and what is the result of similar query in Loki. Are they both same? So if you have both the data same, then only I can put up a similar alert here, right?
Okay.
So this is the...
That was just to check if your query language is giving the same results.
Yeah. So once
that was one-time test kind of thing.
That was just for migration of alerts. Once I was sure that 100 times if I asked to check if both queries are same, it will give me exact same result. I started migrating all the alerts. So that there has to be no manual intervention in between. Because humans might make mistakes in these cases.
Okay, right. Thank you for the photo. Huh? I'll ask more questions if every time you click a photo.
I have a question here. So you said for the compliance purposes, you ran both systems in parallel.
Yeah.
Loki and the other one. So how did you manage to, like, right from the FluentBit itself, you had two FluentBit set up, or how was it basically?
So what happened was that in FluentBit, you have a basic output plugin where you say that where my logs will go. So we just appended both the endpoints over there so that from FluentBit itself, it goes to CoreLogics and Loki. Basically, two output paths instead of just one.
Two appenders in the FluentBit is what you configured in every...
Sorry?
You basically configured two appenders in the FluentBit.
Yeah.
Okay.
Initially, it was just the CoreLogics endpoint with the particular plugin which it was supporting, the HTTP plugin. Now we just appended the Loki plugin over there, which it sends to Loki as well.
You mentioned compliance being okay for just 1 year of data, but I'm assuming that's 1 year of hot data, queryable data, and the rest of it is still going to cold storage.
Yeah.
Okay. And how long are you keeping it in cold storage for?
It's as of now, we are keeping it for like entire time.
So what does this Loki exactly does? Because from FluentBit, you can directly forward to your CloudWatch also. Indirectly, it is storing in S3. Right. So what exactly Loki is doing here?
So what Loki is basically trying to do here is that it has two paths. The two main paths are that first is your write path. That whatever the logs are coming from your agent, be it FluentBit something else, it sends it to a distributor whose responsibility is to just hash your entire stream. Once that hashing is done, it decides which ingester to send the logs. Ingester is the component which is doing all the compression, building the chunk. On that layer, you decide that how frequently you want to flush that data from my ingester to your object storage. So this is the entire write path. Now, the second thing is your read path. in read path, I mention that, let's say, just go and check if this data is in the cache. If it is on the cache, return me. If it is not in the cache, go and check if it is still in the disk of ingester, the Loki's cache. Loki is basically a set of multiple microservices. So it will now go and see your ingester, that do you have the data in your memory or on your disk? If you have, just give it to me. If you don't have, go and just query S3, whose index is kept with Loki itself. So Loki builds your index and the chunk's location. So each label stream, let's say I write service equal to ABC. In second way, I write service equal to ABC, level equal to error. These both are not same. They both are different log streams. For each log stream, there is an index entry in the index file. And that each index file is mapped to a location in your S3 bucket where the actual chunks are stored. Yeah. Yep.
What are your future use cases like? How do I integrate it with the AI or dashboarding?
So the future use cases are pretty simple. The first one is that we already have the NLP in place, which easily allows the devs to query everything. Second thing is, once we move to ClickHouse, we want to have more on our Grafana layer or the UI layer, that it can do some predictive analysis as well, which we currently don't have. So there are some more use cases as well. But like as in today, I have today we have an MCP server, which is basically used by deployment, basically used by the on-call. So what it does is that it collects your events from recent deployment failure, as in like the deployment failure logs, Loki logs of that application between that time frame, metrics from Victoria metrics, and traces from your Datadog. It sends everything to that MCP server that generates a report that these are the possible issues and this is the log line where that issue is coming from. So you have to go and fix it. So as of now, the developer is just going to that place and seeing that what is a log and how do I fix it. What we want to achieve in the future is that if my AI system knows this is the issue, can it go and directly change my GitHub PR? But that is like for a very, very long term, not as of now, which we are looking. As of now, the main aim is to improve our system, which we currently have, and remove Datadog.
So, sorry, have you joined our Discord?
Yeah, Discord.
Good.
Yes.
So, in benefit of time, we would love to have questions, but I also know we have time, right? I would request everyone to please put in your questions in Discord, and we'll take it up from there. Also, call out to earlier speakers. Please join Discord. We are getting questions in there, right? So yeah, we'll request to take it up. Thank you.
Thank you. That was Nirmaljit for you. Next, I would like to introduce Spriha on a talk about A2A protocol.
Sorry.
I'll share my screen. I can move this way, but I can't move that way.
Only one. Can see you.
Yeah, it can happen. Only once.
One is here. We have.
If you can please tell me the time limit.
See a view. You can.
I'll share my screen.
Yes, you go ahead and check. See what you have to see over there. Okay.
Okay. Hi, everyone. The mic is on, right? Okay, yeah. All right. Okay. So before we go into the topic, so imagine that you've walked into a huge international conference and there are brilliant minds from across the globe there, maybe a physicist from Japan, an engineer from Germany. But here's the catch. All of them speak in different languages, so they don't understand each other necessarily. So there would be complete communication breakdown, right? So in this case, you'd need a small army of individual translators or a universal translator, something like Google Translate, translating everything in real time. And then collaboration would ignite, ideas would flow. So similarly, a few decades ago when computers had just started coming out, they were all powerful networks, but there was no way for computers to interact with each other. And then came the TCP/IP protocol. Yeah, it didn't invent computers, but it gave them a universal language in which computers could interact with each other. And that in turn unleashed the power of the internet. So today we are also at a similar inflection point with AI agents. Every organization is also building AI agents. So for anyone who's new to AI agents, very briefly, I'll say what is an AI agent? You can think of it as a specialized bot or a smart assistant for a very specific purpose. For example, a payment agent will process your payment. A marketing agent may generate ideas for marketing. So yes, everyone's building AI agents, but like those early computer systems, the challenge is all of them are fragmented. There's no way that they can interact with each other. And the answer to that aims to be the A2A protocol or the agent-to-agent protocol, which aims to provide a standardized way in which agents can communicate with each other. So in today's talk, if you've been following the tech news, A2A was very recently introduced by Google in the Cloud Next conference just 2 months ago. So in today's talk, we'll explore what it is, and it will hopefully leave you with something that you can go explore more about, tinker with, and maybe at the end, we can also discuss if A2A you think can be what TCP/IP was to the internet. All right. So this is the agenda we'll cover today. So let's start with what is A2A. Okay, no, let's start with a meme. So this is when your dev teams try to integrate AI agents the old way. And what is the old way? That is building custom integrations. So it is not that earlier AI agents would not interact with each other before A2A came, but to make two AI agents interact, there would have to be a human developer who would have to come in and write some custom code. But that would lead to scalability challenges because as you make a change in one agent, you have to replicate the same change in your other agents as well. So yes, that would lead to a scalability challenge, of course. So yes, A2A was very recently announced in early April, and no, it wasn't an April Fool's joke, though it sounded too good to be true at the time. And why do I say too good to be true is because, so as you can see, the beauty of the A2A protocol is that each agent it's very easy to make an agent A2A compliant. That is, each agent just exposes one HTTP endpoint, and you have to set up a small JSON card. We'll also be seeing a demo later, but I'll keep the demo for the end because demos are always the most cool part. So yeah, so it's very easy to make any agent A2A compliant. So imagine suddenly that if you've built an AI agent, you can suddenly make it 100x more scalable because it can interact with, say, Google's agent or Microsoft's agent, or even some quirky agent your friend may have built over the weekend. Okay, why A2A? So right now, every organization like Anthropic, OpenAI, Google, they have their own frameworks of building agents. But the concern is that every framework has its own data format, its own API endpoint, own communication method. So there's lack of interoperability. These agents don't understand each other necessarily. If you wish to make them interact, you have to introduce a human developer who has to write some custom code. And as the person writes custom code, if there's one change in one agent, the same change has to be replicated in all the agents that is speaking to. So that increases the chances of errors, scalability comes down, and also there's no standard way of maintaining the life cycle. That is, if a task is in progress or submitted, or what's the status of the task, there's no standard way of knowing that when multiple agents are communicating today. So A2A aims to answer all of these questions. Moving on, yeah, so one does not simply scale AI agents without A2A, unless, of course, you want a scalability nightmare. All right, okay. A2A and MCP. So when I had told my team that I'll be speaking on this topic, my teammate Vishweshwar, the first question that he asked me is here today, that MCP is already a well-established protocol for models and agents. So why A2A? Is it in competition with MCP? And I think that's a question many of you may be having in your mind. So let's look at this diagram here. So this is one AI agent. It does some processing of its own. And for doing that, it has to interact with some other data sources, tools, and that it does through the MCP protocol or the model context protocol. But when one AI agent has to interact with another AI agent, till some time ago, there was no standard way of doing that. So A2A comes in there. So if you see in this ecosystem, there's space for both MCP as well as A2A. They're not subtracting from each other. So earlier I had also named my slide A2A versus MCP, but later on I changed it to A2A hearts MCP because both of them are complementing each other if you see. So yes, the main difference between MCP and A2A is that MCP is when a model or an agent is interacting with other tools and APIs, and A2A is when two agents are interacting with each other. And this also makes agents even more easier to distribute. So this is one more diagrammatic representation. You can think of this agent in organization A, say in my organization, maybe it's a Gmail agent that analyzes my mails. And you can think of this agent in one of your organizations, and maybe it schedules your meetings. So this agent will interact with some APIs through MCP to analyze and take out information from the mails and say this is a meeting scheduling agent. So depending on what information it gets, it will schedule meetings. So these two agents will interact with each other across the organizational boundary via the A2A protocol. But to do their own internal processing, it will use MCP to interact with other APIs and other tools. Okay. Now we'll go to the main concepts. I hope you all are with me till now. Just raise your hand in case you're not. Okay, the main concepts behind A2A. But before we go to that, let's go through a hypothetical scenario. So maybe let me ask one of you, what's your favorite e-commerce platform? Anyone? Amazon, okay, cool. So, OLX. Okay, any platform. Okay, anyway, so say you've ordered something from Amazon and maybe some electronics or anything, and it's not arrived yet. It's been a few days, it shows in transit, and you're wondering where your order is. You are also wondering, maybe I was charged a little extra. Why was this charge there? And you're thinking, can I return it and get something else? So you have a complex, multifaceted query. What would you do in a normal scenario today? Koi uthayega nahi, yeah. Yeah, so you'll call them, you'll have to listen to some music, then they'll say press 1 for something, press 2 for something, you'll be redirected, you'll have to repeat your query, they might redirect you to another department, again you'll have to repeat your query. If you call them again after 2 days, again all context will be lost, you'll have to repeat. Use Twitter? Yeah, that's another way to get faster replies. So anyway, so that's the scenario today. I want you to keep this in mind. Now we'll go through the concepts that power A2A, and then maybe I'll ask one of you again if you think A2A can help simplify this same scenario. Yeah. Okay, so the first one is that of the agent card. So you can think of the agent card as the Aadhaar card of the agent. So it exposes 3 things. One is the agent ID, which is the unique ID of the agent, a description in human readable format of what the agent does, and the tasks and services that it offers. That's basically a schema which has the inputs and the output parameters of what the agent does. So this is just a sample hello world schema that you see here. So any agent that you make A2A compliant will have some agent.json kind of file, and there you'll be defining your agent card and later exposing it through a HTTP endpoint. And one more specialty of agent cards is that it also advertises what the agent does. So earlier, if there were multiple agents, a human would have to come in and make those agents interact with each other. But with the agent card, what happens is if there are multiple agents on a network, one agent can find out another agent. For example, say you're building an agent to sell a catalog of items and you wish to integrate payments there, but you don't need to do it on your own. You can look for payment agents. You can fetch the agent card of other payment agents, and whichever meets your criteria, you can send a request to that particular agent. So dynamic discovery is a feature that A2A brings with the agent card. You have some question?
there a central repository of agents like very old? How you broadcast someone a payment?
Yes, so there should be a central repository where all the agents are there. Right now, there is another protocol that is being created, I think, by Cisco. They are creating the repository as well. But right now, A2A, I do not think has the repository, but something probably they'll be doing. So yes, this is another meme when A2A actually lets your agents see each other for the very first time. Because earlier, agents would not know what they are doing. Okay. The next one is that of the A2A server. It's very similar to the server client concept. So you can think of the server as the ears of the agent. It basically listens for incoming requests, does some processing, and sends back a response. This skill that you see here, this is also actually defined in the agent card, but the implementation of this skill happens in the server. It also provides security. And the A2A client, so if the server was the ears of the agent, the client is the eyes of the agent. It basically looks for other agents that can do a particular task and sends a message that do this task, and then it delegates tasks and then waits for a response. Why do I say waits for a response is that, sometimes you send a message to a friend and then they don't reply for 2-3 days and you're wondering if they've even seen your message. But what happens here is A2A takes care of all that because constant status notifications are sent back to the client who had delegated the task. So even if there are error responses, that is sent back to the client. Sorry? Yeah, based on the capabilities that are advertised in the agent card. So this is a very simple representation. You can think of this A2A client belonging to one agent, agent 1, this server belonging to another agent, agent 2. So the client of one agent can fetch the agent card of the other agent. If it meets its purpose, it can generate a task ID and send a request to the second agent to do a particular task and get back the response from it. And the last concept that I'll be speaking about now is that of the A2A task. It's self-explanatory, but yeah, it's the most fundamental unit of work that an agent will be doing. And most of the times, the A2A task is designed in such a way that it can be done independently. And yeah, it has a structured request with a task ID input and return parameters. So let's come back to our e-commerce example. Now that you've heard of all the concepts, tell me if you think, you can take inspiration from this, but tell me if you think this same example can be simplified. Yes.
Yeah.
Yes.
Am I audible?
Yes.
Yeah.
Hi.
So suppose if you are a company and you are opening an office in India, so you have to take permissions from 50 different departments, right? Those 50 different departments have different APIs and different processes. And I need to know where my file is in various departments. So maybe I can use this A2A protocol and ask it where the status of the file is, where it is stuck, and it can give me the summary of the whole thing.
Yeah. So this is an answer. What's your name? Samanvay. Nice name. Okay. So this is an answer to this question that you were saying, or just a generic example where it can be used.
It's similar.
Yes, it's similar, right? So yes, the thing is that in this case, they will have to have their own AI agents. If they do not have AI agents, then they can't use the A2A protocol. So yes, if those 50 departments have built their AI agents, then it's very easy to do the interaction. Yes.
I'm talking about the answer to this.
Yes.
User come in and now request the customer interaction agent. Because your query says, where is my order? It goes to the order fulfillment agent. The order fulfillment agent would probably see where is the order. I think the change in the amount, probably it might have to think it has to reach the billing agent. Probably
Yes.
it goes to server and fetches. Okay, there is an agent called.
Yeah, maybe there were extra taxes or something it returns and
it reaches the billing
Right.
agents and then
yes.
same goes for the.
Yes.
What is the agent, or can I simply use Gemini to talk to them directly?
So I think you can, if you use Gemini, you'll still have to, you can use Gemini within these agents. These agents can be using Gemini as the model internally. Yeah, so then you can add them to an agent space and do the rest.
Excuse me, before going further, can you just answer like how, this agent's A2A protocol is, we can run it as at a global scale as a internet, or within an organization also in a local,
You can run it both at a global scale or at a local scale. Only criteria is that the agent that you're running it with should be compliant with it.
So at a global scale, is it already running today?
Yes, yes. I'll be showing you that in the last slide. There are over 50 technology partners who are contributing to it on open source. And yeah, it is currently.
How do agents find each other?
So yes,
What
that's where
function
the,
behind that? No, but the cards, like they are just floating around.
they're just floating around. So either a central repository is there, or right now, if there are multiple agents on a network, they have to know the HTTP endpoint of other agents and then query the cards. And
So each time
find out.
agent comes on the platform, maybe on the network.
Yeah.
So it receives all the agents on the platform, agent cards of all the agents on the platform.
So that is how you design your system. Right now, a registry is being built by one of the protocols, and there they are adding multiple agents. But right now, only your known agents for whom you know the HTTP endpoint can be queried.
My question.
So yes, that is there. And maybe later, I think, is what they will be building a registry or something of the sort.
Yeah, actually, I had a question on the similar lines. So if there are capabilities which are getting served by multiple agents, then which one will you like pick up from that?
That is a decision your agent has to make. That is how you design your agent to make a
Okay.
decision.
Would A2A support some weightage to a agent saying, okay, this is
No,
agent which is reliable?
A2A is neutral.
Okay.
That is a logic that your agent has to, you have to inbuilt in your agent. Yes, from the metadata, it can decide there are 2-3 agents that are doing the same support. Where is it from? And then based on that, you have to make a decision.
Because like how we compare it to Google search, like it gives weightage to some of the links and those are on top and then the others go down. So is it something
No,
available in it?
protocol should be neutral. It should not be giving weightage to anything. Your agent has to decide which one it wants to send the request to.
Okay.
You had this thing on this
I
card.
suggest that this customer interaction agent is kind of a master agent which
Yes.
understands the query and then redirects it to the appropriate
Right.
agent, which may be an answer to the question which a lot of people have been asking.
Right,
Just knowing which agent to call is decided by a master agent.
right. So, yes. Okay, cool.
I had a question, like based on the card that you showed, right? It had something called skill in it.
Yes.
Is there a vocabulary of skills that you've already defined as part of A2A? Or
No. So everyone who is building the agent has to define the skills in the card.
then how will someone consuming, so let's say you have a way of distributing cards and all that,
Hmm.
but anyone looks up at a card and how would you interpret it without having a vocabulary of skills?
Oh, I'm sorry, I don't understand.
See, you're saying, speaking English, I'm understanding.
Yes,
I know the words that you're speaking,
Yes.
know what the meaning of it is. Skills are like that, right?
yes,
When you say speaking is a skill, presentation is a skill. So we know what to expect. Now, an agent talking and discovering another agent, it'll just get a card with the list of skills in it, is what I understood.
yes,
Syntax of that
yes.
particular payload. So how do I interpret the skill if there is no meaning attached to a skill? There should be something mapping skills and what it means, right?
So I think that is again something that you, for example, if you have built an agent and you're looking for a skill, so you have to tell your agent, these are the skills I'm looking for. And based on that,
Because
The-
agent is something that does one particular thing and it's obviously purpose built for that thing. Or you want to reuse it, it means that that is the exact same skill I need and this is how it is known in a general parlance. So that has to be your, see, the A2A thing.
needs to understand the vocabulary,
Yeah.
right? Yeah.
This is good. It will be leveraged only if that is a common topic.
Yes, yes, there should be a common point and it should understand. Yes.
So that's not covered as part of the protocol.
That is not covered as part of the protocol. So that is, I think, something that the agent will inherently understand based on what it has been trained with and what its logic is. I'm not very sure of the answer, but that is what I think will be happening. Yeah, if anyone says, yes, yes, exactly.
A2A client will give the context that they can.
No, all that is fine, but the point is, this agent has got a particular skill set, a particular skill, basically. Like let's take Alexa. Alexa has skills. So if I need a particular skill, I will ask for that skill to be downloaded. That means there's somewhere a repository of skills and what a skill is.
Can we, yeah, let's
Questions?
speak
Questions
about.
over in Discord, and Discord link is
Oh, I'm not
bit.ly/LS.
done, but
No, no.
Okay.
When
yeah.
continue.
Yeah, you can send more of your questions on Discord. All right, okay, fine. Coming back to the example. So you now send a multifaceted query to the customer interaction agent. And now what I want to point out is it parallelly can delegate the tasks to these other multiple agents. So parallel processing can happen. And also context is maintained at the client. So if you come back to the conversation after 2 days, it's not like you have to repeat everything again. Context is maintained. So, this is like a conductor and an orchestra sending out musical notes to the musicians. Okay, now we have a demo. So let me play the demo. So this is something I just tried out from the official GitHub repository. You can just have a look. Official GitHub repository of A2A. As you can see, it has some A2A samples here. You can read the documentation also. The specifications and documentations of A2A are another repository. And right now we'll run some samples and we'll see how it goes. So what they've done here is they've also provided a demo UI which we can use to add multiple agents that are using A2A protocol. So let's try that out. Okay, so I have my code. I have the same code cloned here. So, okay, so let's start the UI first. So it starts and let's open this. So this is the UI that they have built and we can add multiple agents here. So now let's start up 2 other agents also that we can later on add in this UI and we can see if in the same conversation context, we can speak to both the agents. Okay, so this is one of the sample agents that was there. This is a currency converter agent that I'm going to run now. So as you can see in the main.py file of this, the agent card has been set up and the agent capabilities have been mentioned here. Okay, so this has started running on localhost 10,000 port. Now what we can do is once we start an agent that is A2A.
Sorry.
And we can take the address where it's running and we can go back to the UI and we can go to agents and we can add that agent here. So when we say read, it automatically detects from the agent card that it's a currency agent, which can help with exchange rates for currencies. So let's save this agent. Now let's try to run one more agent. Okay, so I have one more agent set up here. Okay, so this one is for a reimbursement purpose. So let's also start up this agent and keep. Okay, so this is running on another port. So let's go ahead and also add this agent to our UI. Okay. So again, once we give the address of the agent, it detects that it's a reimbursement agent and the description and input and output modes. Basically, this information comes from the agent card of the agent. So let's save it. So now we have 2 agents added here. Now let's try to start a conversation. Now, depending on the prompt we give, it will detect which agent the task has to be delegated to. Let's ask
What is 40 USD in INR? It gives a response. Now they say reimburse 40 USD for meal expenses. Which employee should I reimburse? Okay, let me get my name. Okay, so it's asking for the date. So maybe let's give it some date and let's submit the request. So it says, okay, I've reimbursed Priya for this request ID that it had generated on its own. So as you can see, 2 agents were called in this conversation. And if we also go to the event list, you can see all the logs are maintained here. When an agent was called, what was the ID, what was the role, whether it was the currency agent, the reimbursement agent, the conversation ID. So all of that is maintained. The response that came, everything is the status, task status completed or not, task status submitted. As I was telling you that the life cycle is managed. So all that is done here, and you can see a task list also. Here the task list is also populated. So that's how multi-agent communication can work very smoothly once you enable A2A.
All right, and this videos will also be available on the Discord channel later. Okay. So yes, moving on. Okay, and this is the official GitHub repository of A2A by Google. You can go explore it later at your own time. They've included some sample agents that you can just try out. And yeah, sure. There's also documentation around this. And yes, so yes, is A2A seriously ready for enterprise? So earlier, when an enterprise would build an AI agent, they would have to think of all of these things like security and monitoring from scratch and implement them. But with A2A, all of that becomes standardized. Like we just saw at the end, all the events were getting logged. So monitoring, etc. For example, one agent will have some logging pattern, another agent may have another logging pattern. But with A2A, it gets standardized, so one agent can understand the logs of another agent as well. And yes, the benefits of A2A. So if it was not clear till now, there are many benefits of A2A. The first one being standardized and lightweight communication. What do we mean? A2A is based on the well understood patterns of HTTPS, JSON, which are equipped to handle large amounts of traffic in distributed networks. Decoupling of agents, we saw that a decentralized kind of architecture is supported where there's no central orchestrator that can act as a bottleneck. Parallelly, tasks can be distributed across agents. Client-server model with task-based interaction is again a very well understood pattern in distributed computing. And yes, lifecycle management, that is, if your task is in pending state, submitted, what is the status at every moment, there will be notifications that will be sent back to the client. And modularity, because even if one agent fails, you can discover some other agent and delegate your task to that. So these are some of the benefits of A2A. And right now, there are 50 plus technology partners who are contributing to A2A on open source. Microsoft joined the bandwagon just a few weeks ago. And so you understand it's just not just a Google-wide standard, but an industry-wide push towards interoperability. So yes, that was all. You can connect with me on LinkedIn, or you can subscribe to my YouTube channel also if you want. And that was all. Thank you. But the question I want to end with is, do you think this can be what TCP/IP was to be internet?
Yes.
Yes.
I have one question.
Yeah.
But where is the Amazon packet that we were supposed
Oh yeah. We'll get to it.
Okay.
Okay. Thank you. Yes.
Yeah, can you hand over the mic?
Yeah, like you said, as MCP protocol is which is already present, can't we use that to extend like support functions like what A2 is doing? So like why do we need A2 when MCP protocol which is already?
So both of them are supporting different things, but it's actually a debatable topic because there's a section of people who say that since MCP is already supporting communication between agents and tools, why can't it be extended to support communication between agents as well? So I think that can also go both ways, that A2A can also support communication between agents and tools then. But yeah, that's something we'll have to see in the future how things turn out.
Okay.
Yeah, I have a question. So there is a protocol called N8N, which does the AI automation workflow.
Okay.
So how do you resemble between these two?
I'm not aware of this protocol, so I'm not sure.
Okay.
Yeah. Thank you.
Can you ping it in the Discord?
Yeah, you can ping it and then we can look up and
Yeah.
tell you.
Yeah, thank you. I think we can move on.
Okay, thank you so much.
So I think many of you doesn't have the Discord link with you. I'd like to share the Discord link so that you can go ahead and yeah. Okay, so please go ahead and scan it so that you can go to the LSP channel. Is the scanning working or should I increase the, it's fine?
Okay, so we are heading to the last talk. After this, we will have a lighter snack and we'll also do some networking and photo session. Thank you.
So I would like to welcome Turja Chowdhury for the next talk on scaling an internal developer platform to 75,000 engineers. Yeah.
Awesome. Awesome. Thank you so much, guys. Thank you to the LSP team also, right? The large scale production engineering team. And again, thank you to the audience, right? First of all, a huge thank you to all of you. You should also thank yourself also because you are here on a Saturday, right? So it's not easy, right? Especially in this weather. And a shout out to the amazing organizing team, right? I have organized a few of them back in Kolkata. This is complicated, right? The logistics are complicated. So thank you to all of you. The topic of this talk is scaling an internal developer platform to roughly 75,000 developers/engineers. So who am I? I currently work in a Big Four consulting company as a global platform success leader. I have been in the industry for roughly 14 years. I worked in Samsung Research, PwC, Accenture, now I'm in this. I'm also a CNCF platform working group committee member. I am a contributor to many things related to platform engineering overall. So that's I think I'm, let's say, somehow suited to talk about these things. Again, this is a disclaimer. This is not me representing any official views. Again, I work in a company who takes these things very seriously. So this is more like saving myself from their lawyers. Okay, overall agenda is very simple, right? Some context setting, right? Because context always helps, right? And then a point of view on platform engineering. Finally, some key learnings, which I think is interesting, right? Because we have been building a platform for roughly 6 years now. So that might help in some closing thoughts. Okay, let's get started. So with some context setting. So let's imagine an ideal day in the life of a developer. Okay, building an application within an enterprise. So he logs into his laptop, he codes a little, deploys some infra, let's run AWS Google, deploys the code using some sort of a pipeline, and then finally relaxes with some beer, right? So that's what we feel, right, is an ideal sort of a life cycle of a developer in an enterprise. But in most enterprises, you will see this is not so easy, right? Enterprises have a way of making IT very chaotic, right? When I say enterprises, these are not startups, right? These are companies. For example, the company I work in has 450,000 employees, right? So obviously, this is a big enterprise, so their IT inherently becomes very chaotic, right? And what essentially happens, if you see some of the surveys that was done interviewing some enterprise companies. So for example, if you see, let's say, what does a developer need when they're shipping a new feature, right? They would like an environment where they can deploy the new feature. Simple, right? It's just a very simple environment. But just to get an environment, in some cases, can take 4 to 6 weeks. Even a very simple preview sort of environment, which is enterprise grade, production ready environment. So if you see most of the cases, what the survey showed is that in most cases, the developers themselves have zero access, right? Zero access to set up an environment on their own. They need to rely on some sort of a shared IT model. They have to raise a ticket. Okay, I need this Kubernetes cluster, give that to me, then I will deploy my code, which makes complicated the stuff really complicated, right? Same if you see, same kind of concept is saying, right? Most of the devs do not have a lot of access to the actual environment. You want the log in a production grade, you have to go to your, let's say, SRE team or ops team or something like that, right? Or for example, you have a CI/CD pipeline which deploys the infra, but you need your manager's approval to deploy, even to run the CI/CD pipeline. Right? That's how most of the enterprises even today work. So in reality, what ends up happening, right? So you start coding, right? You kind of try to check in something, but at the end of the day, nothing gets, you end up doing nothing basically most of the day, right? So I have spent in enterprises where, for example, I have just run a build and then I've just hanged around the entire day without doing anything because I now have to wait for somebody in IT who will feel, okay, I will set up the environment when I want to and all of that, right? So essentially, it ends up with a lot of frustration, especially for developers. And you might think, oh, my enterprise is not like that, right? My enterprise, I have a lot of freedom, I have a lot of, let's say, flexibility, but then you are really the lucky one, right? If you see some of the surveys, so I will just give you an example. For example, what is lead time? Lead time is the time it takes for an idea in your mind to go to production. So you have an idea in your mind, you go in, you start coding, right? You push the code, you commit the code, finally it has to be released and somehow it will be deployed to production. So in many cases, the lead time is more than months. Many cases, right? The lead time actually is more than months. There are still companies who deploy once or twice a year. Right, obviously not Amazon or Google, we know they used to deploy a lot, but most enterprises, right, they don't, if you see deployment frequency, a few times per year. So there are companies who are deploying once or twice a year, right? And we are talking about CI/CD and all of that, but that is the reality of the enterprise IT overall. So in this section, what I just wanted to kind of drive your attention to into the fact is that we have so much AI, we have so many things, right? MCP servers, this and that, Terraform. But at the heart of the story, if you really work with some enterprises, right? Most of the enterprises, if you see, let's say a bank or something, or a life insurance company, you will end up seeing that IT inherently is very chaotic, right? Enterprise IT is very chaotic, very complicated. And the standard model, right, of let's say I have built a code, now I need to raise a ticket and have somebody spin up the infra and then I deploy the code, essentially is not agile. Right, and then that ends up with a lot of frustration, especially for developers who want to code and see something happen, right? Very quick feedback cycles and all of that. So enterprise IT is kind of like the opposite of agile, mostly. So with this, I wanted to introduce to this concept that has now gained a lot of traction. Gartner is saying this is the 4th important technology trend of 2025. Okay, so that's called platform engineering. So again, what is a platform? This is somebody called Ivan Bocher from ThoughtWorks who defined platform as basically a foundation of self-serving APIs, tools, knowledge support, which is arranged as a compelling internal product. So it's an internal platform. A platform is inherently internal. And then what happens is that delivery teams, the teams who are building actually business-facing products, they take components of the platform and then they build business-facing products on top of the platform. How does this look like? So essentially, most of us, right, most of us are in this sort of a section. So we build products which we build for clients. Clients can be external people, clients can be internal applications. So I might build a payroll application, I might build a banking application, all of this are here. But this is what I'm talking about. This is the team I lead, right, in my company. This is called a platform team. So platform team is essentially an internal team. Their customer is the rest of the organization. Okay, so kind of like the SRE also to some extent, right? Or production engineering sort of a concept, but this has been taken to another level. So platform is managed by the platform team. And then you, as a product team in the company, you will use some parts of the platform. What do I mean by that? So for example, in our company, we ingest a lot of data from clients, right? Clients give us a lot of data. So we need to do an antivirus check on the data. Very simple thing, right? Because we don't know, right, what sort of data the client is giving us. So you'd like to put the data in some sort of a landing zone, ELZ kind of a DMZ zone. Then I want to run some antivirus check on the data. And if the data file has a virus, I want to report to the client. I don't want it in my network, right? So let's say there are 3 product teams, all of them are ingesting client data. Now let's say all of them build their own antivirus solutions. This person builds an antivirus solution on, let's say, Azure Defender for storage, they use semantic protection engine, whatever they're using, right? But is there any value in doing that, right? So basically, essentially what will happen in this case is some of these common functionalities will basically boil down to the platform. So the platform will be managing. So within the platform, there will be an antivirus offering, let's call it. So I need to use antivirus. I will just go in, I will say, okay, I need an antivirus offering or something like that, kind of like SaaS, but within the company, right? So basically, you're providing technology as an offering to the rest of the organization, right? This is at a very high level, the thought process. And what is platform engineering? The art of building a platform is called platform engineering, essentially. So there are different components of platform engineering, which I will go through a little bit. But again, this is just for you to understand what this concept is. So, and this I was telling you, right? This is the 4th important trend that they are saying, right? But before all of that, why? So today, if you see, so when I started in Samsung research in 2012, so when I was an Android developer, right? One of the very old phones, Note 2. So that's where I started, right? My career. So at that time, I remember I used to log into my laptop. I used to use Eclipse, right? IDE for Java. And I used to log into the laptop. I used to write some code. I used to check in the code. And the source control was Perforce. And I used to go home, basically. I really did not care about tracing, Kubernetes deployment.yaml files, right? Too much, right? So we are saying shift left, but we are actually shifting the pressure of running a full-fledged production setup to a developer, right? Essentially, right? That is what shift left is to some extent doing. So if you see, the cognitive load on developers today is tremendous. We say a full stack developer, I want a full stack developer, but what is a full stack developer? Is it really possible for the same developer to write very nice code with solid principles in mind? At the same time, no Kubernetes also, what is the difference between let's say IPAM plugin versus all of the different things, then no Grafana, Prometheus, all of this, right? This is complicated, right? So if you see, the overall idea of a platform is you push the cognitive load down to the platform layer. So you say, okay, I need, let's say, observability, just like they were saying, right? I need observability as a thing, but now I don't manage it. I will push my logs, you take care of the compliance, PIA, everything. I just don't care. When I need something, I will call an API, I will get the data. I don't really want to think about all of this. And as I said, you can take this platform to a very high level. For example, the platform that we have built, we spend roughly $380 million on Azure every year. Right, so this is the kind of money we are spending on Microsoft Azure. We are mostly on Azure because we audit both Amazon and Google. So we cannot do a lot of business with them today, but that's why we are mostly on Azure. But again, at the end of the day, why do we have this concept of platform? This is important. I think if you have a sort of a key takeaway, you should think that, okay, in every company, in some way or the other, we are ending up with 2 types of teams, right? So if I show you this thing again, this is very important. So either you are in this team, which is most of us where we are building products, but at the same time, there is high chance that your company has a platform team. Again, they might call themselves SRE team. Some of them might call themselves, I don't know, whatever, right? Some sort of a team, shared services team or something. But you will end up having something of this nature. And I will explain when in the last 6 years of building our platform, what is the difference essentially between an IT shared services, which existed since Infosys started IT, right? And a platform, right? So what is the difference? What are some of the key traits that makes a platform, some of the things that we learned, but very important to understand that this team, the client is not a business team. They really don't care. So for example, we don't even know who is the business in many cases. Our business is the rest of the developers. I just want to satisfy all of the developers in my organization so that they get whatever they need from this central platform. If I can do that, my platform is a success. If my developers so as I said, right, we have roughly 75,000 odd developers. If those developers can build applications and without having to have a lot of cognitive load, then the platform is a success, basically, right? So that is the only metric. So now if you see, as I was saying, right, still platform engineering is a relatively new concept. right? It's not as much of a concept. Let's say like DevOps was first announced in 2006, right? And the word was coined, I think, in 2006 in our daily conference. But this, if you see, most of the platform engineering teams have only a tenure of up to 2 years. So this is still a relatively new concept, but it is gaining a lot of traction. Why I say it's gaining a lot of traction? This is actually a survey done by Google, right? So in this survey, what Google is saying, they've interviewed, let's say, 100 companies. I'm just taking 100 as a number. They're saying out of the 100 companies, 92 companies are already evaluating platform engineering or are planning to evaluate platform engineering. Only 8% are saying I have no plans to implement platform engineering. So if I copy this whole thing into this room, so let's say in this room we have 100 people, there's a high chance 92 of you belong to a company who already has some sort of a platform engineering, either already implemented or they are in the plans to do that. That's what this is showing. So this is really sort of something that is kind of taking a lot of traction. So again, platform engineering is a huge concept. Okay, so you can, so CNCF has now taken a lot, as I said, right, I'm part of the CNCF platform working group. We just co-authored the first certification exam on this called CMPA, Cloud Native Platform Engineering Associate Certification. So there's a lot of work happening on internal developer platforms. As I said, there's a high chance your companies already have an internal developer platform. They might be calling it something else, or they will plan to. So it's a good time to kind of go to your boss and say, okay, man, what is the internal platform thing? Is there a platform in my company and all of that? Okay. So now, this is, for example, a reference architecture of a platform. Again, it's a very complicated thing. So at a very high level, what happens is that, so we have some sort of a developer-facing portal. This you might have heard about Spotify's Backstage, many of you. So Spotify Backstage is one of the most popular internal developer portal, IDP. This is also called IDP. So this is, for example, you have a front end, right? Where somebody, as I was telling you, the antivirus offering. So how will a developer know there is an antivirus offering? So there should be some sort of a portal where every developer in the company can go. They can go and search antivirus. They will see all of the antivirus offerings. Then they will say consume. They will click on that button, and then some sort of a license key or whatever is a consumption method will be displayed. Some will be API keys. Some might be a direct deployment on your Kubernetes cluster, some sort of a daemon service, whatever. But then what happens is you have this, if you see the integration. So for example, many people will use Terraform to set up the infrastructure. So all of this is abstractions. A developer only sees this. This is everything that is managed by the platform team. One important thing is the platform is always built on some sort of an infrastructure platform, mostly cloud-based platforms. So there is no competition. See, nobody can survive if they, for example, try to compete with, let's say, Google, Amazon, and Microsoft on base compute network storage, right? We have all learned that the hard way, right? So the idea of always your platform is it's a floating platform. Floating means you kind of build your platform on top of the hyperscaler. Whatever the hyperscaler is giving, let's say the hyperscaler is giving you Azure Key Vault. You don't really need to build another Key Vault engine. You provide some sort of an abstraction to the developers so they can integrate Key Vault very easily into your overall orchestration. But what happens is that, as I said, right, reference architectures tend to break at scale. Right? Because a reference architecture is just that. It's a reference architecture, right? That then when you implement that architecture over 4 to 5 years, that's when you actually learn a lot of cool stuff. So just to give you an example of the scale that we have, right? I told you, right, we are one of the top 5 customers of Azure in the world. Actually, we are the second, but that's what we have heard. Roughly 75,000 odd tech community in our firm, which being served by this platform. 3,000 business-facing applications. I told you, right? There are business-facing applications, and then there is an internal platform. So we have roughly 3,000 business-facing applications, which serve 69,000 clients that runs on top of our platform. 2 million users are kind of logging in. Again, when I say 2 million users, you might say, okay, you just said 75,000 developers, then how does this 2 million come in? I told you, right? So the development platform or the developer platform is an internal platform. External clients cannot log into that platform. Only developers will use that platform. But then you build applications on top of that platform, business-facing applications. Those are the applications that the rest of the organization will see. As I said, we are available in 60 global locations and 27,000, roughly low-code, 270,000 low-code developers we support. So when we have been building this platform for the last 6 years, right? What did we learn, right? This is what does, right? How do we scale not only technology, but the rest of the organization? So what we learned is that the best platform or any sort of thing, the best technology is actually invisible. What I mean by that is that it's so ingrained in your workflow and processes that you really don't feel you're using a technology. Right, that's kind of what Android did, right? To a large extent, right? So if you can make whatever, and there's the same construct, right? Whether you're building an application, you're building an agent or whatever, right? You can embed it into the overall experience so much that developers don't even feel they're using a platform. That's like the holy grail of a platform, right? So as you can, Bill Gates is saying, the advance of technology is based on making it fit in such a way that you don't even really notice it. So that's always our target from day one. We ingrain our platform so much into the developers' daily workflows that it kind of comes natural to them. They should not even think, okay, now I need to use a platform. It should be so ingrained into their thought processes. To do that, I am sharing a few key insights, again, in no order of priority, that helped us. So first thing is a platform has to be self-service. This is the most important thing. If it is not self-service, then it's not a platform. Then it's shared IT, which always had. So let's say you have a platform which provides you Kubernetes clusters, or it provides you observability as a service, whatever, right? It has to be self-service. It cannot be you send a mail or I raise a ticket. After 2 days, somebody comes in and sets up something. No. The moment you do that, then you kind of break that whole construct of a full-fledged automated platform. So you have to spend the effort. For example, in our company, if a platform producer, so we call them producer, we're trying to build stuff that the rest of the company will consume. They come to me and say, okay, I have this new thing. Can you approve it? If it is not self-service, I don't approve. Right? That doesn't mean, so unless and until you provide something which is self-service, I will never let you be on my marketplace. Platform as a product. So the platform itself has to be treated as a product. In our company, we have this chief platform officer. So basically, right, Spotify has a chief product officer. Most of the companies have chief product officer. We have a chief product officer just for the platform. So if you come to me, again, I cannot share all of this, some of them are confidential, but if you come to me and say, okay, Turja, can you share me what will happen in that platform for the next 12 months, I can actually share you for the next 24 months. I have a roadmap for my platform for the next 24 years, just like Microsoft has a roadmap for Kubernetes, let's say, for the next 24 months. So you have to treat your platform as a product, and you have to say, okay, you have to publish your roadmap, right? You have to treat it as a product. You have to take new inputs from your business stakeholders. Everything that you need to do, you need to do. Bottlenecks. So again, I think some of us anybody who has been working on scalability, right, understand this concept of a bottleneck. So sometimes we feel that, okay, I will be on a cloud platform, so then there is no bottleneck. But every single thing in IT has a bottleneck. The bottleneck can be our technology. It can even be people. People can also be a bottleneck. In this case, for example, just to give an example, so we had built up a solution, as I said, right? We had to build an end-to-end data supply chain. And it kind of depended on a shared SFTP folder. So everything is scalable, right? Everything is using Microsoft Fabric, Azure Data Fabric, Kubernetes on, let's say, auto-scaling clusters, right? So no matter how many transactions come, it will auto-scale and kind of downsize. But in your architecture, if you have just a single SFTP folder, let's say, for example, right, then it can kind of make a bottleneck. So this is something we have understood, that when you want to build something that is scalable and automated, you have to look at every single part of the supply chain, every single. A simple MySQL DB server or a simple SFTP folder, just a simple SFTP folder can kind of destroy your overall, let's say, scalability of the application. People and process. This is also very important. So as I said, right, my company has 450,000 employees. So my thought process in our company is always that we can scale the technology, right? We can scale the technology to an extent with cloud, but can we scale processes? What do I mean by that? So for example, with GenAI, most of our developers now want to do POCs on generative AI. Every day they have their partners and business leaders telling them, guys, can you show me how to, let's say, build an AI agent as an example, right? Which was being shown. So what does a developer need to build an AI agent? They need some sort of an LLM. And an LLM cannot be mostly hosted on your laptop, right? Unless and until you have an Apple or something like that, right? Mostly you will need a cloud-based LLM. So essentially, you basically need an API key for an OpenAI or Anthropic or Gemini, right? So what happens in our company is that whenever you request an OpenAI from our platform, there are 5 levels of approvals that are there, after which you get an OpenAI. Why? Because people are concerned, right? They will use an OpenAI, what sort of data they will give, will they follow any bias, responsible AI, all of that. So how do you scale your workflow? So OpenAI is very scalable. Microsoft will say, okay, you can increase the number of tokens as much as you want, but is my process scalable? Do I have as many people? So if tomorrow 1,000 people request OpenAI, or let's say I go to a change management board, CAB meeting, most of you I think understand what a CAB, and in CAB you have one person who is approving, suddenly if you have 1,000 changes in a weekend, does that scale? Your technology might scale, but does your process and people also scale? This is something we learned the hard way. And evolution, right? So when we started the platform 4 to 5 years back, right, the thought process and what it is now is kind of like you will not even recognize it. Right? Even we cannot recognize, right? Even the intent, the philosophy, everything has changed. So spending time by injecting flexibility into your architecture always pays off in the long run, especially if you are in the big game of building platforms and products. So always you have to think, okay, what can I do to make this as flexible as possible? Without obviously adding a lot of cost, but we need to inject flexibility, right? So what is architecture, guys? Architecture is basically the thought process of deciding something now in as much flexible a way so that I don't have to pay the cost of changing it later. Basically, that is what architecture at a high level is. So always thinking about evolutionary architectures when building platforms helps. Decision records. So I told you, right, we have been building a platform for 2018. I don't know how many people have left the organization, how many people have joined, right, over the time. So sometimes you might not even know why somebody did something, because that person is not even in the firm, right? He has gone maybe, let's say he has resigned 2 to 3 years back. So having this sort of a decision record, again, whether it's an ADR architecture decision record or some sort of a decision record, has helped us a lot. So today, if you come to, so in the last 3 years since we implemented ADRs, I can tell you why we took this decision of, let's say, using, just as an example, using an asynchronous format of processing this data versus a synchronous. At that time in November 2021, I can tell you. And then we can decide whether the decision was correct or not. But at least we know what that engineer was thinking at that time when he has implemented that decision. Inner source. So in our company, we have 75,000 developers, roughly, right? And our platform engineering team is roughly 630 people. So how can we scale to the demand of the entire organization? Is very complicated, because today one developer will come and say, no, I want, just like I said, right, A2A, I want to integrate with A2A, I want MCP, and we will take a lot of time in building that as a platform offering, right? We will take some time. So the idea is to adopt some sort of an inner source. What is inner source? Inner source is open source for the enterprise. So it's very nice concept. You guys can check it out when you want. So the idea that we have in our platform is, let's say you're a developer and you have built something cool. Let's say antivirus. Let's say we don't have an antivirus offering. You have built your own antivirus offering. Then we have a way, of inner source, where we call it platform convergence, so that you can contribute it back to the central platform, so that the rest of the organization can then use it. So this is called inner source, kind of like open source. That's what open source exists on, right? But this is for within the enterprise. Buy versus build. There was a very interesting session, right, on when they moved from a SaaS sort of a offering to an inbuilt sort of a Cred. I think the guy from Cred was presenting that they built an inbuilt platform. So, and it was OSS, right? They use Loki and whatever, right? But so there is this saying about OSS that OSS is as much free as a puppy is free. So if I gift you a puppy, you will say, oh man, Tuja gave it to me for free. Very nice. Tuja is a good person. But you still have to feed the puppy. Right. So basically, there is a maintenance cost and all of that. So for our company, we always decide on buy versus build. Should I buy it from the vendor or should I build it? We build only when it's very strategic and we want to protect the IP, we want to keep the IP with us. But for example, an observability solution, most likely we will not build it from scratch. We will, like you said, maybe take Datadog or something, because we are okay with it. And we kind of, let's say, outsource the pain of managing something at scale to the vendor. So buy versus build is important. Knowing your customer, this is very important, because see, when we started, right, when something starts, something like this, right, who gives the money? The money normally comes from the business, right? The CIOs or something like that, right? But in a developer portal or platform, the problem is the customer is not that same guy who is giving you money. Mostly, your customer is the person who gives you money. Somebody comes and gives you $1 million to build an application, you listen to him because he is the person giving you money. But in our case, the money is coming from, let's say, the CIO, but the persona I have to cater to is the developers. So knowing the customer is very important, that the customer of an internal developer platform is the rest of the organization's developers. not the CIO, not the business. So whatever the business is, obviously they're giving the money. They're an important stakeholder, but they're not your customer. This is something we learned the hard way. And as I said, scalability, right? So there is this inherent thought process that many of us have, right? Okay, we are on the cloud, we are automatically scalable, right? But it is actually not true. We have learned it the hard way. I think some of you might have also learned the hard way. Yes, cloud has kind of made many things very simple for us, but you still have to inject a lot of focused thought process, especially as I said, right? Whenever you are building something that 75,000 developers will use, which will finally serve, let's say 69,000 odd clients, right? 2 million logins. You need to inject scalability and, as I said, right, address bottlenecks across the supply chain. So if you think of your software as a supply chain, starting from source code to the target deployment, every single step you have to kind of use a magnifying glass and say, okay, man, is this part scalable? Is this part scalable? Just because I have used, as I said, just because you have used a, let's say, Spanner database, maybe the database itself is scalable, but how am I putting the data on that? Right? Is it also scalable enough? So things like that. And avoiding the rabbit hole. So this is something we struggled with for a long time. So technology platforms have a habit of morphing into business platforms. Right? Because as I said, the money comes from the business. So business users, so I regularly get into calls where a partner from Switzerland will say, okay, can you host a payroll application on your platform? Many of my guys need a payroll application. And I strongly said, no, this is not something your business might need it. Your business users, your analysts are needing it, but your developer doesn't need it. So kind of keeping that constraint sort of a thought process that, okay, this is a developer platform. Only my developers will be on this platform, not the business. You're paying for it, but you will get the benefit of the platform in an indirect way, not a direct way. So having the distinction between a technology platform and a business platform really helps. So as I said, right, very quickly, so we have been building this thing called a platform for, let's say, 5 to 6 years, right? Especially when we started when it was not so cool, when Gartner was not saying it is the 4th important thing in the world, right, of technology. So we learned a lot of this stuff the hard way, right? We have spent, I don't know, close to a lot of dollars, right? I cannot say the exact numbers, but we have spent a lot of dollars in building this. And if somebody else is building this now, right, whether building from scratch or taking something, a vendor product, there is a product for Humanitech, Spot.io, Backstage, many people are implementing. These are some of the things that if you guys kind of keep an eye out for, that might help you. And closing thoughts, this is the platform I was talking about. We call ourselves EY Fabric. Okay, this is a platform you can kind of go and check out on it. I wanted to show a lot of more stuff on the actual platform, but my company did not allow that essentially, right? Because I had to go through a lot of processes and approvals and all, so I could not show you all, but this is an actual public facing link. If anybody is interested later, they can go and check out our platform. This is the same platform that is serving, as I said, right? We are roughly consuming 4th largest consumption of Azure and all of that. And a good, yeah. Okay. And as I said, right, a good platform, building a good platform takes time. So this is again a survey that was done by Google Cloud. So they're saying most of the leading platform companies, right, they spent more than 5 years or 3 to 5 years building their platform. So it's a very complicated thing and it takes time. And there is a maturity journey. This is a CNCF platform engineering maturity roadmap. How you can become, let's say, from a provisional platform to an operational. This in itself is a talk, right? I even have a talk on this on YouTube if you guys want to check out. So how do you, it's just like everything else in your life, there is a maturity sort of a path, right? You start from an immature platform to a more mature platform and you do a few of the stuff, but it's worth the wait. See, at the end of the day, why do we do all of this? So again, we are in Google Office. So this was another survey that was done by Google. So Google is saying, right, Google Cloud surveys thing, teams who have invested in platforms can deploy to production 8 times more likely. They're more likely to deploy in production by 8 times in less than an hour than people who have not implemented platforms. So implementing platform gives you that ability, end of the day, to deploy more quickly. And the more you deploy, the more value you generate for the business. Nothing else, right? Your code sitting on a GitHub repository is useless unless and until it translates into somebody's website or somebody's phone or something, right? When somebody, a user interacts with your code, that's when it generates value for the enterprise. Till that time that your code is in production, the code is essentially kind of useless, very frankly, right? So I will end the session with this quote, right, which I really like. So the technology we use impresses no one. The experience you create with it is everything. So essentially at the end of the day, right, whether we are building, let's say, the platform or whatever we call it, right, shared services, SRE, what is the experience that your consumer is getting out of it? If the experience is seamless, if they feel that, okay, the product is, when you use a cool product, right, you get that feeling, right? Okay, man, this is a really nice product. It kind of understands what I need. So your internal products and platforms needs to have the same philosophy. Just because it's an internal platform and just because the consumers are developers doesn't mean we should kind of treat it as something else. Perfect. So this was me. Thank you so much again for, I know we are kind of on time as well. So if any questions, more than happy to answer. Yes, exactly. See, as I said, right, I mean, onboarding, see, first of all, there are many companies, it's like a balancing game. So in some cases, the companies are mandating the developers to use the platform. So they will say that, okay, you have to, whatever you build has to be on that platform. But at the same time, there is a concept of a habitable platform. A habitable platform is where you don't mandate anybody to use the platform. They use it because of their choice. So this is like a chasm sort of a thing. You might initially need to push people a little bit, right? So that at least, otherwise what will happen, right? See, money is being spent on the platform team, right? At the end of the money is money, right? You have to show some return on investment somewhere down the line. You cannot just say, I am a philosophical team, I will just keep on building stuff without people using it. So for example, we have a platform insights team who measures the consumption of the platform. We measure how many logins are coming in, is it increasing, decreasing? If it is very low consumption, our business will not fund us, right, for the next year. So there is some mandate we have to do some cases, but at the end of the day, if you make it easy, see, at the end of, when a developer joins, so Spotify measures a metric called time to first commit. So what is it? When a developer joins a company, what is the number of days it takes that developer to push a PR into production? So you will see many companies, it is 4 to 5 months. 4 to 5 months is the time. So that 4 to 5 months, you are actually paying the developer for doing nothing in a way. He's just understanding how the company works, this and that. So with this sort of a platform, for example, in our platform, you can onboard a developer within 2 to 3 days. So that is something we measure. How much time does it take? And that's when you convince the rest of the developers and the rest of the organization saying, guys, if you use our platform, developer onboarding is so smooth. We give you all of the licenses, we give you the IDs. So it's a mix and match of stuff.
Okay, and does this add another layer of learning curve for the developer? Like in case some outage comes or any logs they want to check, and the customer they're working for has some issues. Now they have to go through this platform infrastructure to.
Only if, as I said, right, see, the goal of your platform should be that you don't even, so it's like, for example, saying that you are using, let's say you're using Azure. You have to go to Azure Log Analytics to see the logs, right? Will you really think that, okay, I have to go to Azure Log Analytics, it's not a good thing. So if you can make your platform so ingrained into the workflow intuitively, right, providing guidance, then people will not mind as long as they get what they need. If you introduce delays, as I said, right, if let's say there are still companies where developers have no access to production environment, even to get the logs, you have to raise a ticket. So just imagine the frustration of the developer, right? Something has failed, now he has to wait 2 days to see what was the log. Then he has to push just another debug log. That will take another 1 week to go into production. Then the next week he will get the actual result, right? So it's like very complicated. That's why I'm saying, right? So these are some of the things, if you make it, if you help your developer, the developer will kind of come back to you.
Yeah, so I have like, sorry guys.
Please go ahead.
See, it's really cool. Like you have a platform where developers can, directly get what they want. But at the same time, like a company would have a lot of rules and policies in place. So imagine you would have something like various roles defined that who can access what and up to what extent. That is one part of it. And the second part is perhaps like inbuilt in your platform, you would also have some triggers like which kind of, send an, if not a mail, a notification to the required person that so and so person is accessing.
So just like everything else, obviously there is logging, auditing, all of that is anyways there, right? You cannot provision something without people knowing. So first thing is within our platform, the first thing you have to give is a charge code. Because it's not free, right? Infrastructure is not free. So somebody has to, I will not pay for it, right? I will not, the platform team will not pay $380 million to Azure, right? You are consuming Azure, you will pay for it. So the first thing in our platform is you will have to give a charge code. Only then that charge code has to be approved by the business. Those things are anyways there. So as I said, right, that's why I said, right, it's important also that the platform also helps scale the process and the people, not just the technology. Many times we say, okay, I have scaled the technology, I have used a Kubernetes cluster and all. The Kubernetes cluster is very nice, it's scalable, GKE, all of that. But is the process also scalable? If you need an approval which takes 2 weeks to get a GKE cluster, who cares, right, whether GKE cluster is self-service or not? So it's like a combination of both. You have to have all of that. And that's already inbuilt into the platform.
You can bypass all that approval by creating predefined roles or limiting access. Because if everybody can do anything, then I mean, doesn't it bypass your organizational policies?
Actually, the platform today, for example, within our company, before the platform, we had many people using their credit cards to get stuff done. Because the developers are also very creative, right? If their boss gives you some work, they will find a way to do it. Right? They will use their credit card, they will use somebody else's subscription, they will do whatever they want just to get the job done and go home. Right? So basically with this platform, because we made it more simple, with all of the controls, like you're saying, they're already there. It's not like anybody can do anything without any oversight. It has much more oversight now and a much more streamlined intake process. So today I can say, okay, this subscription, so we have roughly 8,900,000 subscriptions overall in Azure. I can say which subscription belongs to who. That I can do just because of this platform, because everything has been provisioned through the platform. If outside the platform, I have no visibility. So rather governance is actually improving with the platform than without the platform.
So you have legalized everything which was earlier being done illegally, in a way of speaking.
Okay, thank you all. We come to an end for today. We will be sharing a feedback link. Or he'll put across a QR code. Please feel free to